did we develop C-Trek? C-Trek, one of the things that as a consulting company, we were contracted on many occasions to do performance tuning and problem determination. From the performance tuning point of view, we would wind up, going to account A and doing a certain type of research and analysis and so on. And then we go to account B and we found ourselves repeating the same type of information or searches that we were doing before for the previous account. And as we went, from account A to B to C to D, we found that there was a pattern of things that we needed to see. For example, one of the first things you want to do is look at the SIT. And well, we found out that, if we sit there and look at the SIT, well, why not have something that will look at the SIT for us by just, saying, find it, tell us what's going on. And it'll identify those parameters in the SIT that need attention. So that's part of the thing that we decided and why we decided to develop C-Trek. It's, trying to take the amount of repetition that we were doing every time we went from one account to the other. And we wanted to identify areas as fast as possible. So part of the things that we wanted to do is to reduce the time and cost in spending that you spent tuning a system. In many occasions, before we developed the tool, you spend 200-300 hours just trying to tune a couple of CICS systems. But as CICS systems got rapidly expanding in the sense that originally, when you looked at CICS back, 40 years ago, people had maybe one or two or three systems. Now today, they can have accounts that have hundreds of them. And to try and tune hundreds of them, spending 200 hours on each one was just too much. So this is one of the things that we do with C-Trek. The other thing that C-Trek does is that it takes and things that you would have to do, like manual calculations to try and determine, the parameter was correct or not. Well, that sort of thing, C-Trek will do it for you. Things, for example, do you have the right CI size, or do we have the right free space that we have to allocate, or do we have the number of L8 TCVs allocated to the particular DB2 entry? That's the sort of thing that that we would that C-Trek will determine for you, and will apply the formulas for you directly. Things, for example, in the VSAM, do we have a particular CI size of the index, which is prone to have key compression problems? Okay, well, that formulas and that sort of thing are all built into the product for you. And we will see more a little bit later. The way that C-Trek runs is really just a transaction running within CICS. It's a conversational transaction in the sense that it does not use any CPU time unless you hit the enter key or hit some PF key to get it activated. So it's from a performance point of view, CPU environment, it's not very expensive, because it's not like your monitors, which have active transactions running with normally somewhere between 4 and 6% the cost of using these your normal performance monitors that have these transactions are active all the time. It will perform the analysis of the CICS system and specifically the type of the thing that you want to look at. So you only spend the amount of CPU on the basis of what you're looking for. And it provides information. Some of the information is from a tuning point of view, and some of the other ones from a problem determination point of view, which you can identify things that can lead to problems. It also provides information in the internal structure. And I'll show you when we see the menu, the detailed menu. You will see that every single domain that's within CICS has an entry in the table, in the menu, and you can look at the different things. Now, there's some domains, for example, the message domain. There's not really much information there from a tuning point of view or a problem determination point of view that you want to look at. It just sort of gives you the information as to what you have defined. But there are others, for example, such as the dispatcher domain, where you would not only be able to see what the dispatcher tasks, the queues with the dispatcher are, and they're waiting, or if they've been dispatched, that sort of thing. You'll be able to see in more detail. Also, an important sort of thing thing, which is sort of a curious sort of thing. I was taking a course many moons ago regarding the dispatching priority that you have. And we're accustomed to a one byte dispatching priority, which is basically, the transaction, the user, and the terminal. You would get up to 255, you add them up together, and you round it off to a maximum of 255. However, the dispatcher uses an 8 byte priority, okay? And that 8 byte priority, of which that 1 byte is part of it, of the priority itself. And so I was curious to find out what it was. And it turned out that it was important as to what it was, as to how it was used. And with the dispatcher, we would be able to see something called the QRQ. QR meaning the QRTCB, and the Q meaning who's waiting on it. And you could tell by using this transaction or this option within CIC, within CTRAC, that you would be able to see if you're getting queues, people getting queued up for lack of CPU, and that sort of thing. But I didn't put that in, but that's sort of the sort of things that you would want to, if you want to go into the detail of each one of the domains that you can find, and so on. The other thing is as it provides an internal structure, you will be able to learn quite a bit about how CICS is structured, and what the different domains are and what their importance are within CICS. You will be able to see, if you want to see a particular control block, CTRAC provides the addresses of these blocks, and you can see the control block in memory. Now, IBM stopped providing the supplemental data areas back in version 4.1, but you can still see them, see these control blocks, and and see what the information is in there. CTRAC will provide, what I call, in it's plain old English, the important fields of each one of these control blocks. And as I mentioned again, it provides a health check, and that's really where you will start your tuning process, which is looking as to tell me what in the system needs attention. And we will see a little bit about this. And so it's, as I mentioned, it's over 400 tests today, and we're currently programming 5 additional ones. So it's something that we keep expanding and so on. Okay, so we found, that CTRAC can help anyone, who uses it to be able to identify in less than an hour. Actually, if you run the health check, which will do the analysis for you, that health check runs in 5 or 6, 9 or 10 seconds. It uses maybe 200 or 300 millisecond. It goes out there and looks at every single control block, every single definition that you have out there, and identifies the areas that need attention. Okay, but in less than 1 hour, you can take your most complex system and understand what areas you have to look at to try and perform, do a tuning or whatever you may need to do to improve the utilization of the resources. By utilization of the resources, I mean, for example, something like you'd be surprised how many people have BSAM files defined that have a free space allocated, and they never do an insert. It's a fixed length type record, so they don't even expand the record or modify the length. So and that's space that you're losing in the disk drives. Okay, and you can recover. So these are sort of things that CTRAC will do, and you'll do it differently than a performance monitor, for example. You'll get the information, but many times you just get the information, do any analysis for you. You have to sit there and analyze it as such. You'll see that it has 10% free space, but you don't know if that 10% is sufficiently large enough to accommodate a record. Okay, so you have to sit there and calculate that yourself to make sure that it's correct. And when you would do it normally one record, one sub file at a time, versus CTRAC, they would look at all the files in one shot, okay, and then come back with a list of all the files themselves, so you can basically adjust, make the adjustments you need. Any questions so far? Something which is very important is that CTRAC is not a monitor. CTRAC is not designed to replace OmegaMon or TMon or SysView or MainView. It basically, the installations that have C-Trek is coincide, they live side by side. Users use it to get information, and that the monitor that does not provide. And you will see some of this information as we go through this. Okay. Okay. Now, even though it's not a monitor, there are some things that we provide that are similar to what you can get in the monitor. For example, I can see a list of all the tasks that are running in the region. Okay, well, the monitor gives you that information also. However, we give you other information that the monitor does not give. For example, in the case of a task that's running under LE, language environment, we provide the trace table for the LE, the outcome problem, and we can provide you monitors can provide you the storage that they're using, the total storage, but maybe not necessarily the individual blocks of the storage. And not only do we provide the individual blocks, but we give you the address. And if you wanted to look at that particular piece of storage, you just put your cursor on there and hit BF5, and that will take you to storage and show you what that control block or that piece of storage contains. So even though we do provide some of the information that the monitors provide, the way that we provide the information is completely different to the T1 or Omega provide them for you. Now, again, the design of C-Trek is not to start giving you things like response times and that sort of. That's what you have your SMF information, or you have your monitor information to do that. Our information is basically how that task is running. The other thing which is interesting is that C-Trek captures the information when it goes in there. And if you wanted to see the information after the task has finished, since it captured the information, can give you that information. But if something like OmegaMon, for example, the task that finished, and you want to see the information of the task, it's no longer available. So that's some of the differences. The other that C-Trek will highlight for you in either yellow or red. Yellow meaning warning, red, that's something you have to pay attention to. And the areas you may want to look at a little bit more in detail. Okay. Okay. Now, C-Trek, as I mentioned, does the calculations for you, and it analyzes the information. And for example, it'll go out there and analyze the entire temporary storage queue, or it'll go out there and analyze all the information you have in DB2, all the DB2 entries, the pool, and so on. So at one shot, it goes out there and analyzes, the whole that you're looking at, and then from there you can then select what additional details you want by selecting, give me more info, a particular task or a particular resource that you want to see it, and it looks at the common rule of thumb type environments. It'll look at it and basically identify areas that need attention, that you need to look at it the way you want it or not. Okay. It also provides a help type deal that it provides the information as to, okay, this is why we're taking you, and this is what we recommend that you look at, and this is what you can do to fix it. Okay. So all that information is in there. And again, it also provides the ZOS, the operating system information. You'll see the menu, and we'll go into the details of it. Some of the screens you'll be able to see in detail. Okay. Okay. Now, we have found that customers who have implemented C-Trek have been able to identify sleeping type problems, and things that you didn't know were there, but all of a sudden, C-Trek will identify that you have a potential little situation building up, and you can basically take advantage before it can cause any problems. The customers have also found that by doing the things that C-Trek recommends, you'll be able to improve your response times, and at the same time, in many cases, reduce your CPU utilization. Okay, and one of the things that a lot of people with C-Trek is they find out how CICS works, and since you will be able to see all the different domains and their queues and their controls and so on, you will be able to understand, the architecture of CICS using C-Track. Okay, and as I mentioned, it has the product itself is developed in COBOL, displays and so on, but the access to the control blocks and the information gathered from the CICS control blocks is in assembler. So we have something like over 1,000 COBOL programs, and we have maybe 300 or 400 assembler programs in there. Okay, but it's one big module. In other words, you don't really see it. You'll get it. One of the things we do with C-Track a little bit different than the concept of SMP, is that we provide the changes as we develop them, and we'll send you a new copy when you request it, and that new copy will have all the PTFs applied, and will have also any new enhancements that we've made to the product. So anytime you reinstall C-Track, you will get the latest copy of the latest PTFs, changes, and so on. And so you don't have to be messing around with SMP to maintain C-Track itself. Okay, now, some of the areas that that C-Track will look at is things like how well is your VSAM files defined. Okay, again, if you're working with Omegamon, for example, Omegamon will present the information regarding a particular file, but will not analyze for you how well it was defined as such. Okay, it'll also tell you things like that you won't be able to see with any monitor at that point. Is how many data and index buffers are allocated by file, and specifically, I'm talking about LSR files. In other words, you today will normally will look at in Omegamon, TMON, you'll see your LSR pools, and it'll tell you, okay, the 2K block, you have 500 buffers allocated and so on, and you have a 92% look-aside hit ratio. But out of that 500 buffers, what files are being used, how many are using it, how many buffers are allocated per file, and so on. That sort of thing C-Track will provide for you, and that's because when you read it says that a particular file is monopolizing a particular buffer, how do you reach that conclusion? Then the only conclusion that the only statistic that you have is how many exec CICSs you did to the file. But you can do a million exec CICSs to one buffer. It doesn't mean that you have a million buffers allocated because you have a million CICSs. Well, C-Track will provide the information as to how many buffers in the LSR pool, both in the data and the index, are allocated to each one of the files. And you will be able to see, yeah, this file is really monopolizing the pool. And I'll show you a screen that shows you. And by the way, I'm using our test system, and our test system, is very low volume, doesn't have a lot of activity, but at least you get an idea as to what the thing does. The other thing which is important is the buffer fragmentation. C-Track identifies whenever you have a buffer fragmentation. In this particular case, that it identifies it is that you have, for example, you have a 10K CI size, okay, but you didn't define a 12K CI size. So it's going to be using the next size, which may be a 16K or a 20K. That sort of thing is automatically identified by C-Track. But also C-Track goes in a little bit further, and it'll tell you how it's costing you when you use a 10K CI size for within a 12K LSR buffer. And the reason is you have to remember that CICS only supports 11 CICS buffer sizes, but you have 28 different types CI sizes. So you're going to get some type of fragmentation out there, and what you want to do is make sure that it's the minimum. And we'll talk a little bit more about that a little bit further. Okay. There's also it identifies things for you that can cause unusual. Not so much unusual, but the loss of virtual storage. We went into one account that was having a problem with virtual storage below the line, and it would, every 2 or 3 days it goes short on storage on the system, and they would, in many cases, they had to reinitialize CICS to recover. Now, C-Track in there and did an analysis for them, and they found out they had like 8,000 terminals defined, and each one of the 8,000 terminals had 255 bytes allocated to the TCP UA. Ctrek did an analysis for them and said, look, the highest position that you're using in your TCP UA is position number 42. So, from position 42 or 43 to 255 is basically wasted storage. So they did that analysis for a week or so, and they came to the conclusion that 42 was really the highest position. And they lowered the TCP UA allocation from 256 to 128. And they didn't have the short on storage condition from there on below the line because they recovered that virtual storage. Okay, so that's the sort of thing that Ctrek does, which are hidden type things that you won't be able to see with a performance monitor as such. The other thing is Ctrek will also tell you how well you're working, how your reuse percentage is with the allocations that you have for your TCBs or your L8 or your threads that you have for the pool and DB2 entries and so on. And again, the simple one, which is identifies those SIT parameters that need attention. That you may not, and you may want it that way, but it alerts you that it may not be the best alternative that you want.